Hey guys, welcome back. Mr. Marone here. We are in section 6.4, which is kind of an interesting section. It's really just a different way of phrasing what we just learned about parallelograms. So all of this stuff is now we're proving whether or not a quadrilateral is a parallelogram. So before, you were given parallelograms and you worked from there. Now we're going to be trying to determine whether or not we have a parallelogram given a quadrilateral. So on your notes, as you'll see on my screen, there are 5 theorems. They match the 5 different ideas that we know about parallelograms. So we know, if we made our quick list, we know that our opposite sides are parallel to each other. We know our opposite sides are congruent to each other. We know that our opposite angles are congruent. We know that our consecutive angles are going to equal 180 degrees when added together. And we know that our diagonals bisect each other. So those are the 5 things that we learned in the last section. Now if you look closely, they tell us here that if the opposite sides of a quadrilateral are congruent, then you have a parallelogram. So it's this one, we're just doing the converse. We're flipping the statements. So if you've got 2 sets of congruent opposite sides, you've got yourself a parallelogram. If you've got 2 sets of consecutive angles, supplementary, you've got yourself a parallelogram. If you've got opposite angles congruent, you've got yourself a parallelogram. If you've got your diagonals bisecting each other, you've got a parallelogram. And then the last one is if you've got a set of congruent sides and they're also parallel, you've got a parallelogram. So it's really just the flip side of what we've already learned, which is kind of neat. So we're going to take a look at a couple examples right now. So the first collection here is, were you given enough information to determine whether or not this is a parallelogram? Well, in this first one, I've got 2 sets of opposite sides congruent. Yeah, we have enough to say that this is a parallelogram. In the second one, I've got my 2 diagonals, and they appear to be bisected, so that would be a yes for me. In number 3, they gave us 2 sets of vertical angles. We don't really know anything about vertical angles in regards to parallelograms, so no, we don't have enough to determine. They could be a parallelogram, we just don't have enough info. In our next one, they gave us 3 of the 4 angle measures. If we add all of these up, we end up with 300 degrees. The inside of every quadrilateral is 360, so if I did 360 minus 300, I get 60 degrees. I now have opposite angles congruent, so that's a yes for me on that one. In our 5th one, they gave us a single set of congruent sides and then this middle side congruent. We don't know anything else about this, so we don't have enough to say what the figure is. In our last one, they've given us opposite sides are parallel by those little triangles and they're congruent. That was that one little nuanced one that was a little different, but it is also true, so that's going to be a yes as well. This type of question that you're going to see in 2 and 3, which I'm going to let you guys try, they are the one way you'll see these questions phrased that are a little different than just solve for x or find side FP. So in this case, they said, for what values of x and y is this a parallelogram? In other words, in order for this to be a parallelogram, we know the opposite sides have to be congruent, right? We know that this side and this side have to be congruent, and I know that this side and this side have to be congruent to each other. So in order to have them congruent, those equations have to be equal to each other. So the process to solve it is the same. The language in the question is going to look a little different. In this case, I have to solve for y first. If you look closely, 2y plus 2 is equal to 3y minus 9. And then my other set is that 3x plus 6 is equal to y plus 4. I can't solve that one yet, but if I solve y first and then solve x, I can get both values. why don't you go ahead and solve that, and when you come back in, the answer will be there. Then we'll take a look at numbers 3 and 3a. All right, welcome back in. So if you notice, I solved out for y, and I found that y equaled 11 in our left equation, and then plugging in and then solving out, I got x equals 3. So when x equals 3 and when y equals 11, FLIP is a parallelogram. Otherwise, it wouldn't be considered a parallelogram. In number 3, this first one, we're going to have to use some algebra that we haven't used in a little bit, but that's okay. So if I were to look at this, they gave me pieces of diagonals. We know that the diagonals of a parallelogram bisect each other. So I know that x equals y plus 2, and I know that y plus 10 equals 2x minus 8. Oh boy, we have two equations and we have two variables. We have ourselves a system of equations here. So we're going to have to use a system of equations here to solve this one. We could use graphing, we could use elimination, but the easiest one to use in this case is substitution. I've already got it set up where I can substitute anywhere there is x, I can put in a y plus 2. So I've got y plus 10 equals 2, and then instead of x, I'm going to put in y plus 2 minus 8. Once we solve for y, we can plug back in to get x. In our second one here, I could use that same method, or I could use my consecutive angles being supplementary. So in that case, 2y plus 4y equals 180. And I can do x plus 5x minus 180 equals 180. So I've got those set up. Why don't you go ahead and try and solve those, and when you come back in, they will be all ready for you. All right, welcome back in. As you can see, y equals 14 and x equals 16 on that first one, and y equals 30 and x equals 60 on the second one. If you need to pause the video and take a look at the algebra, that's perfectly fine. Otherwise, if you have other questions, bring them into school tomorrow, and we can talk about them then. Have a great day, guys. Bye-bye.